Okay, so members, now let's see what happens if they give us the velocity in the ij notation. What happens there? Then they're asking us here the position vector of the particle. So let's go through it. At time t equals 0, a particle is projected with velocity 3I meters per second from a point to the position vector is meters. So they were giving us now the height from the floor. Find the speed direction of the particle when t is equaling to 2 seconds. Now from there, what do we have? So you can draw a simple sketch here. That is going to be where the particle is going to be having this is speed of 3 meters per second. Then this is going to be our flow, so it's going to be falling, of course, like that. So we're doing us that meters. So this one is going to be 5 plus 25 j meters. Okay, you know from here, that particle will reach a point there. This will be RBX, then that will be RBY, then there will be that V, then this is going to be our VY. So now they are asking us to get the velocity, the speed and direction of the particle after 2 seconds. So now they are giving us time. So it means that they need this V. So what happens there? You know that our V, using this diagram here, this is going to be our Vx, and this is our Vy. So they need this velocity there. It means that we need to get Vx and then Vy first. So in our Vx, whenever I see Vx, it means that we are studying velocity in our horizontal motion. So we have u, okay, we have Ru plus At. As we said in the horizontal motion, our acceleration is what? Is 0. So meaning our Vx is going to be equal to u, but our velocity here, which is 3 meters per second. So our Vx is that. Then we need our Vy. What happens to Vy? So our Vy, now here we are assuming we are considering the velocity. There our A, the acceleration is going to be the g, and there we assume, we say that our, if it's just falling, our initial velocity is 0. U plus at, so our Vy will be now 0 plus A, which is 9.8 into our T, which is 2. Is it 2? After 2 seconds, because they're asking us after 2 seconds. So now my Vy will be, that times 2 is going to be 19.6. 19.6 meters per second. That's so now to get my V, the velocity, after they are asking for this velocity after 2 seconds, say it's going to be, which will be square root of, this one is going to be 3 the whole square, then plus 19.6 square, which is going to be 19.8283 meters per second. So that is going to be the velocity after 2 seconds. So after 2 seconds, that's going to be our velocity. Then they're asking us also to get the direction. So our alpha is going to be tan inverse of Vy over Vx, which is going to be our, which is going to be tan inverse of our Vy, which is 19.6 over 3. Okay, so now our alpha is going to be getting 81.3 degrees. So now you can say the velocity in the speed is, you know, the speed is the magnitude of velocity by now. That's why we always get this magnitude, because speed of velocity. So the speed is 19.8283 meters per second at 81.3 degrees below the horizontal, Where our horizontal, that's what we are calling our horizontal. This is our alpha. So now they want us to get the position of the particle when t is equal to 2 seconds. So there, we shall go back to our displacement where I say RT is always equal to R naught, the initial position, then plus S, where our S is given by UT plus a half AT squared. So our S here, because our S here, so remember now we start the particle is moving down like this in that direction. So our S is going to be, so the SY, that initial displacement, that vertical displacement is going to be 0 into T, then plus a half, 9.8 into 3 squared. So our SY is going to be 9 times 4.9, which is 441.1 meters. Okay, so now our R, which is equal to R naught, plus ST plus S. Now, here, this is going to act as our initial. This is going to act as our initial point there. So, when I get into my RT in T, now my initial position, where this particle was initially, is going to be 5 plus that. Then we are going to add on some acceleration, where is the... Okay, now this will be, if now we are dealing with, now this one we are high compression. Now, it means that now we need this point, so meaning our S there is going to be defined by, because this point is moving, this point here, we are going to be having our X, Y. We need the displacement in X, also need the displacement in Y. So this displacement in Y and also in X. So our SY is going to be, we have seen our SY whenever we have U plus 8T squared over 2. Whenever we have the horizontal, the vertical, our U is 0. So our SY now will be 0 into T. Then plus 9.8 over 2 into 3 squared. So from there our SY is going to be 4.9 times 9, which is 44.1 meters. So this was for the one which we have calculated the Y. Then also come for the SX in the X. So it is still UT plus a half AT squared. Because we are in horizontal motion, then acceleration is going to be 0. So from there our Sx is going to be U, our U is saying this is 3. Our U, the initial velocity, which is 3. Then times our time, which is 2. Because we said the R is our U here, is going to be the same as the initial speed there. So our Sx here is going to be 6 meters. So this S we are looking for is given by Sx, then Sy, which will be Sx, which will be 6, then 4.41 meters. So from there now, my RT equaling RO plus S. Now we substitute. Now our initial point, we are going to take this as our initial point because we are showing this particle was at that point, the distance, which is going to be now our R, which is going to be, we are going to take the 5, then 2, then 5, then plus the I, then the J. the I means the x component, then the means the y component. Then the displacement here, the x component is 6, then the y component is 4.1. So which we can easily get as our RFT is going to be 11. Then this one when we add, we get 69.1, and these are in meters. So the particle after 2 seconds is going to be there. So we can put our R after 2 because we have substituted. It's going to be 11I, then plus 69.1 J. These are in meters. So the particle is going to be after 2 seconds. It's going to be there. So that's it, members. Now we are going to see more examples about still this when they asking us to get the distance covered by that particle. Let us see that. See you there.